Okay, here we go. Finish up here, please.
I got
Okay, let's go through this. So real quick, the good news. Okay, there were some things that were commonly missed, and some of it's really easy to fix. Like there were some people that would have had really good tests had they not mixed up, and this happened a number of times. Inverse and converse, right? So get that straight. Which one is which? So if we're let's look at example 1 for a second here. If it's snowing, then the temperature is below 32 degrees. So what's the hypothesis here? Okay, it is snowing, conclusion. Temperature's below 32. Okay, so what does an inverse do? Okay, what does an inverse do? Okay, it negates both of them, exactly. Good. So the inverse is the one where we're gonna make the opposite of both, right? If it is not snowing, then the temperature is not below 32 degrees. Okay, something else that came up. I only took off a point for this, but is it the same thing as saying is the negation of then the temperature is below 32 degrees, then the temperature is above 32 degrees? It's not. How come? Emma, you're right. Because it could be equal to 32. Exactly. Right. So the correct answer is it is not below 32 degrees. It is above 32 degrees. Is not strictly correct, right? What's the converse do then? Switches the hypothesis and conclusion. Right, exactly. And then the contrapositive, which is the hardest one, I mean, people were great on that one, but it was just switching that inverse and converse happened a little bit. And if you did that, it really nailed it. I mean, it was like 16 points. So easy to fix. What else here? I think, as I recall here, oops, what's going on? Here we go. Okay, these were okay, but not perfect. Let's have a quick look at maybe these. The true and false. Determine whether the biconditional statement about the diagram is true or false. Let me... Okay, so what about this? The first one says angles 1 and 2 are supplementary if and only if they form a linear pair. So true or false? Does it make sense? We have to look at it both ways. You give me a true or false for each of the two conditional statements we could get that create the biconditional statement. Okay, there's the conditional statement, if angles 1 and 2 are supplementary, then they form a linear pair. True? True, right? Makes sense, doesn't it? If they're supplementary, in this picture, right, based on this picture here, right, then they form a linear pair. Because it says biconditional statement about the diagram, right, so that might have been a source of confusion, right? You got to make sure you're strictly reading the questions. Okay, what about the converse? If angles 1 and 2 form a linear pair, then they are supplementary. True. So both are true, and so therefore the biconditional statement is true. Questions on that? Okay. Something else that came up just a little bit, minor issue, but you guys are in this class, I want you to be aware of this. So if we do flip that around, as people did for those first questions 1 through 4, if I flip around the hypothesis and the conclusion to form a converse, it's really not good to say it in the hypothesis, right? So like for example here, if we flip this around, we really shouldn't say if they form a linear pair, then angles 1 and 2 are supplementary, right? What we really should do is we should say, see if this makes sense. If angles 1 and 2 form a linear pair, then they are supplementary, right? So you put the pronoun always, if there is one, is going to be in the conclusion, and the proper noun goes in the hypothesis. And that's just English, right? I mean, that makes sense. I didn't mark you off for that, but just be aware of that. What about number 6? Angles 1 and 2 are congruent if and only if angles 1 and 3 are congruent. So based on this picture, once again, let's look at the conditional statement and the converse. True or false? If angles 1 and 2 are congruent, then angles 1 and 3 are congruent. How come?
Because the lines are perpendicular.
Okay, so if angles 1 and 2 are congruent, what does that imply, and they're a linear pair, what does that imply about angles 1 and 2?
180.
Say it again?
Equal 180.
Okay, but if they're congruent, then what would the measure of each one have to be? 90, right? So these have to be right angles, don't they? Right? So if these are right angles, then that implies that angle 3 is also a right angle. Anyway, I mean, from a bunch of different perspectives. We could look at 2 and 3 as vertical angles. We could look at 1 and 3 as a linear pair and therefore supplementary, right? But no matter how you look at that, knowing that these are right angles implies that 3 has to be, and therefore 2 and 1 and 3 are congruent also, right? And this one, doesn't it make sense that this one, for you guys, I want you to see if you can see why this is completely symmetrical, right? If I reverse this statement and we do the converse, if angles 1 and 3 are congruent, then angles 1 and 2 are congruent. We just said the same thing, didn't we? Right? I mean, is there any difference to that relationship than the first one I said? Other than the fact that angle 3 is there and angle 2 is there, big deal, right? See what I'm saying about the symmetry of that statement? The argument is exactly the same, isn't it? If 1 and 3 are congruent, then we know both of those must be right angles, and therefore so must angle 2. Does that make sense? If you think about that, should it make any difference in a situation? I'm looking ahead quite a bit here in geometry, but just I want you to logically think about this for a second. Wouldn't you agree that if I took this whole thing and I just reflected it around a line, I could switch the 2 and the 3, right? Should that make any difference in a problem if I take a picture and I just reflect it in some way? Should that fundamentally impact the relationships between the angles? Shouldn't, should it, right? So that's why I say it's symmetrical. We'll talk about all kinds of symmetry in math and science. In physics, we'll even talk about symmetry with respect to time. And this is a really important skill in math. If you can kind of learn to see when things have symmetry, that is huge because it saves a lot of work. Just a quick example, if I throw a ball up in the air, the ball's gonna go up and come to us, it's gonna get to a point where its velocity is 0 and then it turns around and comes back, right? Would you agree, just by way of example here, that if I were to film that movie on the way up, and then you watched that movie of the ball going up to the top, and then you watched the return flight to your hand, would you know any difference between actually me having filmed the ball falling or me being tricky and having reversed the movie of the ball going up? Does that make sense? Would there be any difference? There wouldn't, would there? Well, we'll talk about that in physics in a few years. But that's also a kind of symmetry with respect to time, right? The time up and the time down are the same. So symmetry is big. What else? These were fine. I think for the most part, there was no issue with any of these problems. If you do have a question about that, come see me. And if there's something that after looking at the answers, you're not sure why, how to do that, please come see me. Yeah, or you got a question?
So, they're all supposed to be conditional statements?
No, they're not. These are not conditional statements, right? Those are just, that's just the negation of the conclusion.
Yeah, I get that, but they're not, they're the if and then.
Oh, that's right. I remember yours. Yeah. No, they're not biconditional. What would biconditional look like? And if and only if how would they be different? Yeah, okay, right. The arrow goes both ways for a biconditional. Okay, good question. Yeah. Any other questions about this? Okay, moving on. These people did by and large very well on these. There were a couple things that I did allow you to do that I think were fine. On number 13, the book says multiplication property of equality, which is the best one, but division property of equality is equivalent essentially, right? We could divide both sides by 1/8, right? So I give you credit for that. I think I might have taken off 1 point out of 2 on that one because it really wasn't the best, but it worked. Okay. This of course is reflexive, right? Does that make sense? Okay. And that one really is just a right answer and a wrong answer. Okay, on this guy right here, on 15, that really is substitution and not transitive. Once again, if you put transitive, I did give you a point out of 2 on that. But you see why this is really not transitive? This really is a case where we're doing an algebra substitution, right? Because it's not like we're saying, we're actually plugging in a value of 4 into an expression 2 times x, right? It's not just saying if a equals b and b equals c, then a equals c, right? Generally speaking, when you're doing algebra, you're doing substitution, right? On this one was, I allowed either addition or subtraction, no penalty on that one. Because adding -1 would have been fine. And then this was transitive, right? Okay. These were pretty good. I mean, I think in virtually every case those were just fine. No real issues with that. Pretty straightforward.
What was 18?
What, say it again?
What was 18?
I got that
I think it was
equals 3.
3, I think.
I got x equals 5.
Because, you know, if you move a +7 over, it's still +7.
Right.
You know, because
We got
28
confused.
plus 7 is 35.
Right.
It is.
That's very true. 28 plus 7 is 35. Okay, so everybody, I mean, how would we do this one? And I can see where people, and you just made now a mistake. That's gonna happen. I'm not worried about those. That won't happen again. I mean, that's just but how would we set this up real quick on 18? Okay, good. The sum of the two expressions equals 28. Simplify and solve for x. No big deal. Everyone's fine with that. This one was, I think this one was fine too.
7 equals each other.
Yep, set them equal to each other, right? Solve for x. Okay, the proofs. I want to go through the proofs. Now, what I did here, you don't see it reflected on these sheets, but for your benefit, what I did is I broke this up into 2 separate 50-point grades. So everything except for the proofs ended up being out of 48 points. And so you could just take your grade, and it'll be on Moodle, like today. So you can look on there and see exactly how it broke down. But if you want to know what your grade is, it's going to be your percentage grade. So whatever, like if you got, for example, if you missed 2 on that one, say you got 46 out of 48, well then you would just do 46 times 48 over 46, right, to get your percentage, times 50, right?
No.
Right? It's the same thing. Same thing, but then multiply by 50 to get the score out of 50, is what I'm saying. Right, so if you got 48, you're just, that's 48 out of 48, right? That's 100%. So you would multiply by 50 over 48, and you get 50. Well, actually, never, you don't need the times 50, sorry. You don't need the times 50, you just multiply by 50 over 48. Right. Which is, does that make sense?
Yeah.
Because that's the combined score. But what I did is, I split them up into separate grades for the proof and for the non-proof stuff, so that for certain people, like if you just mix some stuff up, but you knew what you were doing, you don't have to go redo the proofs, for example, right? Does that make sense? So I'm gonna let you redo one or the other. You don't have to redo both. You can, but you don't have to. What's that? Well, then it can't get worse. That's fine. You can't do worse. I mean, your combined score is not gonna change. You see what I'm saying? That's in the book. That's in the book. But if you want it, if there's part of that you did more poorly on than another part, you could redo that one part, and I'll give you your highest score of the 2.
So did you enter like one?
Okay, shh, why is everybody talking over here? That's not good.
Did you enter one like out of 48 as one test?
Yes.
And
The other one out of 40, right? The proofs are out of 40, but I made them both worth 50 points. So I took their percentage. See what I'm saying? I took their percentage as a decimal times 50. Is really all I did. Does that make sense? So think of it this way: if you got a 90% on a certain section, whatever that might have been, how many points would you get out of 50?
45.
45. 0.9 times 50, right? That's all I'm saying. So I didn't mean to make it more complicated. It's just, you're just calculating your percentage, but then instead of out of 100, it's going to be out of 50. So your percentage divided by 2 is another way to do it.
Okay.
Okay? Make sense?
Yes.
And that way, you'll still have the same overall grade. If you're happy with it, fine. But if you wanna redo just one part or the other, you can.
Oh,
Does that make sense?
Yeah.
Okay. So let's look at the proof. Couple things on the proof. I can give you some strong advice on the proof right away. You don't necessarily have to use,
You piece A little loud, Alex.
no, come on. You don't necessarily have to use 5 steps, right? So there was an optimum way to do the proof that took 5 steps and then took 4 steps. But there were people that started to do this a correct way that just wasn't maybe the exact best way. But if you finished it, I would have given you 100% on it. So, yes, sir.
It has to do with the proofs. Couldn't you just write simplify rather than?
I give you full credit for that if you did. That was fine. Yep. I didn't take anything off for that. I'll get to
I
that.
didn't, I was just.
No, you could have. That would have been fine. So let's look at these. What are the steps? Okay. So the first one is the length of AB equals the length of BC given. Next one.
AB plus BC equals AC.
Okay, good. Based on the picture, right, we could say AB plus BC equals AC. What's the reason? Good. Okay, ideally, what would we do next? And here's where some people kind of went, lost the train of the whole proof here just a little bit. But if you still had I took a lot of time trying to see where you were going with it and award partial credit accordingly. Probably imperfectly, but I did the best I could. So on this one, what would we do next? Substitute. Good. We're gonna substitute BC for AB, right? Other way around, AB for BC.
Either way works.
No,
Either way works.
Okay, but I did it backwards. We're trying to show that 1/2 AC equals BC, right? So the most direct way would be to say BC plus BC equals AC, right?
Substitution.
By substitution. Question?
No.
No? Okay. Now, there's another way to do this, and we'll talk about that also. So this would have been substitution, property of equality. What's next?
Simplify.
Okay, simplify, and there's a number of ways, technically the book says the next step is distributive property, that's fine. But I also, if you just put down algebra or simplify I think is best. We would say BC plus BC is what?
2BC.
Yeah. 2BC equals AC. In my mind, the best justification for that is simplify. That's all you did.
Good writing, algebra.
Nobody did. I would have thought that would have been okay in a way, but I think simplify is the best.
That's just right, algebra for all of them?
No, you can't do that. Okay, last step.
1/2 AC equals BC.
AB plus BC equals BC. Look at picture.
How did you know that I'm smart?
Actually, if somebody just did it, and all the numbers were because I said so.
Yeah. Okay, how's that?
Has that ever
Questions?
happened to you?
Questions? Everybody see that? Okay, but one thing that a lot of people did start to do, which I think would have been fine, was this. They changed things a little bit. When they got to, let's see. I think this part would have been the same. Well, maybe on this one there wasn't another way to do it. I don't think anybody did come up with a different way on this proof. Did anybody have a different approach? Okay, yeah, now, why can't you, okay, that's interesting, 'cause that came up a fair amount, but that's not gonna work. How come that doesn't work?
Because we don't know if it's a middle.
You don't know if it's a midpoint. Right, there's nothing, just because it looks like it in the picture, that's not enough. They would have had to have said be as a midpoint as given information, or they would have had to have done something like that, right? So we knew those segments were congruent. Then we
Don't
could
we
have,
already know
right?
that, but don't we know that AB is equal to BC?
But what if there was something else in between it?
True.
Oh.
Explaining your science.
Yeah, I forgot they gave us that. So if you said midpoint, what did you say? I might have to look at those again. What do you think about that?
I think it's in the hole.
Wait, but couldn't there be like
What-
another segment between?
Okay, but what good, here's the other question though, what good was the midpoint? I can't remember, was there a way to use that anyway?
I don't know.
I don't, that's what it was.
That's why I tried it.
Okay, please raise your hand if you have something like that. Yes, sir.
I just said that it was a midpoint, and then I just finished it. I got BC, it was BC and then substitution.
Okay, so the midpoint really didn't add, okay, so that really didn't add anything to it though. Yeah, gotcha, okay. That's why.
That's all.
Yeah. Does that answer your question?
Okay,
Okay.
then how is that minus 8? I was only made like 2 marks.
Well, if you were, hey, I'm not gonna ask again. When I'm up here, I don't wanna hear a bunch of people talking out there. This is a great group, but this is getting to be a little bit of a problem. So I'm gonna ask one time, and after that, I'm gonna be not such a nice guy. Okay, good question. How did I grade it? Well, I graded on things that were there and things that weren't there. So if there were some keys, like on this one, if there were some of the key steps that were missing, I also took points off for that. So I may not have marked it that way. Does that make sense? Yeah. Okay, so that one, really that one you were kind of tied into one way to do it. But the second one, that wasn't the case. With this guy, there were a bunch of ways, well, I'd say a bunch. There were at least 2, I thought, pretty good ways to do this. And some people started to do maybe the second way, but just didn't finish it properly. But still got pretty good credit for it. So let's first of all go through maybe the most efficient way. So we're given some stuff. Angle 1 and angle 3 are a linear pair. And same thing for angle 2 and angle 3. And what's the reason for both of those? Given, sure, given. What about next step then?
There's something.
Okay, yeah, if they're a linear pair, then by the linear pair postulate, they are supplementary. Good. Now, this happened a couple times. People put measure on there. That's not right, right? You wouldn't say, this is not correct to say the measure of angle 1 and the measure of angle 3 are supplementary. I don't think I took any points off for that, but I made a note to you about that. The measures aren't supplementary. The angles are supplementary, meaning the measures add to 180, right? So this one should have been angle 1 and angle 3 are supplementary. Same thing for angle 2 and angle 3, right? And that's just for both of those. That's linear pair postulate.
Is it alright that I put a definition of supplementary angles?
No, because that's something different.
You gave me credit for that.
I don't think I did. Yeah, okay, that's because you did, I gave you -3 for the whole, for that one?
Yeah, this one. Yeah, you gave me credit for it.
Oh, I shouldn't have. Yeah, I should have. I missed that one. I should have.
Nice job, Tyler.
So what about the next step then?
Angle 1 can be angle 2.
Bingo, that's it, good. Angle 1 is congruent to angle 2, and what's our reason for that?
It supplements.
Very good. So this is the best way to do it. This is a 4-step proof. It's pretty easy.
Okay, you don't have to brag about it.
Congruent, supplements, theorem, and then last step, if the angles are congruent, then measure. By definition of congruent angles, very good. Okay, good, but people could have done something different, and they did. They also said that the measures of angle 1 and angle 3 are 180, which is fine. So we could have, to do this one totally right, we could have just not gone the route that we did right here with 3 and 4. We could have done something else instead. We could have done this. Could have said measure of angle 1 plus measure of angle 3 equals 180. Measure of angle 2 plus measure of angle 3 equals 180 by the definition of supplementary angles. Right? And if you did that, then that was useful because, what did we say? Oh yeah, then we could say by substitution or transitive property, I would have gone either way. If the sum of measures of angle 1 and 3 equal 180, and the measures of angle 2 and angle 3, their sum is 180, then I could substitute and say the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3 by either substitution or transitive property, right? Make sense? We'll just call it transitive, but either one would have worked. And then what would my last step be? Subtraction, yeah. Subtract the measure of angle 3, from both sides, right? Subtract those and I get the measure of angle 1. Equals the measure of angle 2 by subtraction property. I would have given, had that one been done completely, I would have given you full credit for that one also. Okay, so is it the same thing? So, in other words, did you maybe jump right from there to there? If you did that, I would have taken off just a little bit, but not very much. Okay, is that what it was? Yeah.
Wait. Oh. Okay.
Make sense?
Yeah.
And you had another one. You had another, an extra thing that was messed up on yours, yeah. Okay. Make sense?
Wait, so they're worth 6.
They were worth, each of those was worth 10.
Oh.
For a total of 20.
Each of what?
Each of the 2 proofs.
Oh.
Cause I got given, right?
Wait, how much would you?
Oh, I mean, each is worth 20, sorry.
Yeah.
So
each
what-
of the-
So what will I have, like a minus, what will I have to subtract from that?
Just 2. Just 2, yeah.
I don't know.
I was gonna say, how do you
I'm
minus
so
17?
not.
So it's still an 8.
Well, look at that.
Okay, question. Do the what? Oh, yeah. Okay, yeah.
I'm still happy, I'm still happy.
Are you okay?
Let me collect those real quick.
Boy, whatever we check.
When can you?
Yeah, what
Okay, this is important. I'm not gonna do it Monday because it's not a complete period. I'd rather just wait. I won't put these in the grade book till after Thanksgiving. Okay? Make that deal. So we'll go like maybe the Tuesday after Thanksgiving, so you get questions answered on Monday if you want to study. Does that work? We'll go ahead and do it in, what I'll do is I'll split it up so if you're gonna do a retake on one or both parts, you can do that. If you're totally done, you can work on homework. All right, pass those forward, please. Thank you.
I'll get my phone taken away if that happens.
Take those, sir.
Pass it forward.
Ours were in a separate file. Organized.
You're very organized. You saw it.
I know. Okay. I missed that one. I missed one step. And then.
It was getting so fast I couldn't grab
I
it.
know.
I guess he